Today I want to talk about DEP. Why DEP? Because the last time, I wasn't here the last time, but the first time we met, we talked about tooling, and I had the impression that not many people were using DEP, and we are meant to use DEP because DEP is going to be probably going to be the main dependency management tool for Go. And just about me, if you want to contact me with questions or anything about this talk and you don't get there to ask me now, yeah, feel free to contact me on Twitter. It's easy to remember, and or just email address. And that was actually the, I think, a memory leak in a Perl program. So to talk about DEP is important to know the history of the dependency management in Go. And initially, you know, Go was developed in Google, and we were meant to use GoGet, and GoGet would download all the sources into our Go path and build them and compile them all, and everything was neatly organized in Go path, and that worked very well for Google, and because they're using one huge monorepo and they're using probably 50 guys to just maintain the Go path and to clean out old dependencies and new dependencies and put other things in there. For me, it was the hell because I'm working for different companies, and each company has different dependency trees and different versions, and for me it was not really usable. So in, I think, 2016 or something, we were blessed with the Go 1.5 vendor experiment, which started to not only use the Go path as a source for dependencies, but also the .vendor directory, which I'm going to mention a lot in this talk. And with the introduction of the Go 1.5 vendor experiment, we got a long list of package management tools available for Go. And I don't know which ones you're using or know. Oh, there's a mouse there, mouse pointer. I used a few of those. Actually was the happiest with GVT. And I think at the probably 5 or 6 months ago, I totally switched to DEP because everybody was talking about it and I wanted to give it a try, and DEP is actually pretty cool. Just quickly, how a workspace is organized in Go, probably most of you know, but maybe not everybody. You have the Go path, which is anywhere, but usually it's in home Go or something. And then in source, you have different sources, and you have especially the Git repositories checked out from your dependencies. So you say, go get GitHub, com Golang example or something, and go get will check out the sources in your example directory and put it there, and it will fetch the head of that repository. And head is nice, and everybody got used to using head in Go. But now with many packages and many projects running, head is not always a solution. So sometimes you need to have a different version of a package. I was just bitten by one thing. It was Apache Thrift, which has huge development and so many versions, and somehow I was bitten by 2 different versions installed in my environments, and that bit me pretty hard. So it's not good to have just one dependency. Now we got the vendor project layout. It's pretty much the same. You're in Go path, and under Go path somewhere you start your own project, and you have your own Git repository, Git directory, and somewhere you put vendor, and you can add dependencies to your vendor directory. And when you compile or you build your Go binaries, the compiler still looks in Go path source for dependencies, but first it looks in vendor, so you can always override the general system settings. And well, initially, when we started with the Go vendor experiment, you had to do that by hand, and you always had to manage the whole vendor directory by hand, and that usually was an rsync from from GoPath, and then probably git pull or whatever. It was terrible to actually work on that, and I wonder how how Go vendor experiment actually made it to being the default setting with really being so hard to manage. And many people actually switched to using Git submodules, but I don't know if you're using Git much. I hate submodules. I mean, it's a great tool, but it doesn't fit in my brain. I don't know why. So until 2016, we were stuck. And there was, I feel, huge snobism by huge companies, no names said now, and they just said, yeah, do it right, and use the central Go path, and I don't know, do your build system correctly, and nothing will happen to you. But it just didn't work. Not everybody had the environment to, or the power to actually say, okay, you company, you my employer, you have to do it this way, or you have to do it this way. It just didn't work out for me, at least, and I had to switch between 3 different companies, and none of them were actually using the tools applied by the huge companies. So luckily I wasn't the only one who was unhappy, and there was a rescue effort, and people finally accepted, okay, dependency management is hard. It's not as easy as some people said. And we do have a dependency hell. Okay, it was there and we need to fix it. And one of my really favorite guys in the whole Go community, if you have never looked him up or followed his talks or anything, or his ideas, go get some of that, is Peter Bourgeon. And he offered to actually lead a standards committee to do something about dependency hell. And he did, and they selected Sam Boyer to actually develop a tool. It wasn't called Golang Dep, it was called Go Deplang or whatever, some under a different name. And he started hacking with the tool, and people liked the ideas, and they were planning a lot of how we could do dependency management in Go in the future. And Sam is super important, but I want to really mention Carolyn van Slik also, who is becoming super important for the whole Dep development. And I think her name must be on every slide where you have Sam on. I mean, Sam is still the top committer for Dep, but she's picking up really fast. And if there's something you need to know about dependency management and about dependencies of dependencies and dependencies of dependencies of dependencies, ask her. She knows, and she fits it in her brain. I don't know how she does it. And okay, it's a simple tool, as everything with Go. I mean, it's always, everybody's trying to get everything down to simple. And how do you use it? Go get -u, you github.com Golang Dep command dep, and this should install it in your Go path. And to start a project, I mean, you probably have your project already, and you want to start vendoring your project and actually really maintain your dependencies, you just call dep init. I always use the V flag. Dep is still very, very slow, and often you don't see that it's actually doing work. And if you use the V flag, you see, okay, it's working and it's doing this and that, and I don't care what it does it well. And with V, I see it does something. If you don't use V, sometimes it's stuck for a minute and you don't know what's happening, okay? So there's actually an issue on GitHub that they say, if you have dep init or any command and you press Control-C, it should switch to verbose mode because so many people are pressing Control-C and actually breaking things. And so this is initially to get your repository going. And what it does, it creates a manifest in the log file, and we talk about that later. These two files actually manage your dependencies in your project. To add a dependency, just say dep ensure add whatever you need to use. Ensure is the command that you need to know. Okay, if you know dep, init is just something you use once. Ensure is something that you use all the time. Dep status is for fun. Yep, just see how outdated I am. It's like yarn. I don't know, how do you check yarn status? Is it same command? I don't know, but it's nice to look at those lists and see everything that's outdated and update dependencies, and what of course you can do with dep as well. And the important thing here is that it creates Go package log and Go package toml, and it creates those in your project's root directory, and you have to check those into Git. And the manifest is, or just quickly to show what dep from this moment on does whenever you run ensure, it looks at your code and goes through all the code in your project and looks at the import lines, and not only in your code, but also in the dependencies of your code, and looks at all the import lines, makes a graph of the dependencies you have, and it looks in your Go package toml, the manifest, where you can manually override things that it would calculate, and looks at the Go package log, merges the code and the manifest, and then recreates vendor for you whenever you run dep ensure. And in the future, it's not going to recreate vendor, but it's going to fix vendor, which is going to be much quicker than what it does now, because now it has to really check out all the dependencies every time you run ensure. So whenever you don't know what to do and you need a coffee break or something, run dep ensure. It's not a coffee break, yeah. It's like 30 seconds or something. It depends on the size of your project and on the state of your project. Also, don't drop dep at the first time running it. Dep gets faster every time you run it because it uses caching. Dep status, I already told you, it's fun. Dep prune is if you want to, what I'm doing in my project, I'm always checking in vendor. There's pros and cons about checking in vendor directory into your repository. For us, it's currently needed because it's so much faster in the builds. I think we've used, it's taking us, I don't know, a minute to our build system. And if we ran dep ensure every time, we'd use 1.5 minutes, and we don't want to do that. But you can always use dep prune to actually clear your vendor directory from all the unnecessary files. So when you say dep ensure, it downloads all the dependencies and all the repositories your package depends on. And dep prune actually deletes all the files that are not needed by your source code, which is pretty smart, I think. And yeah, what you can always do, which is what dep was actually made for, is you can remove vendor and just run dep ensure, and it will recreate your vendor directory exactly the way it needs to be to run and build your code. Okay. And it's also cool for if you need to visualize what you depend on. And the problem is this is a very small project, and usually, where's my mouse? Usually, if you create that for a real project, it looks like that. And yeah, I think it's probably a useful tool. I haven't found a use for it yet because my graphs look like that. And yeah, it's nice, and you can print it and plot it, and probably if you have a plotter, it's cool to put it on a wall, but otherwise I don't know what for. But it can. You know? And so quickly about the manifest, the Go package toml. This is actually everything you need to know apart from those 4 commands that I put on there. is the Go package toml. It's super simple. I mean, you've probably seen toml files, and it's a simple format. It has, I think, 4 directives that you can use. And if you're using dep, you will probably need to know your Go package toml. When you say dep init, it creates a Go package toml and puts a lot of dependencies in there, and you can maintain them in there and change versions that you want to rely on, or accept them, or I don't know, even delete dependencies from your file, and also just use the log file. You don't need to put every dependency of your project in the Go package toml. You can use the generated log file also to manage dependencies. It has a few syntax elements required. Means, okay, I need this package even if you haven't found it in the source code. So, for example, if you need to generate code or something which cannot be detected from your import lines, then you can say, okay, but I need something in addition to what you found. Please ignore this, which, for example, if you have repositories that are going to be merged from other sources and cannot be just trivially retrieved via git pull or whatever. You can just say ignore this package when generating the log file. Metadata is for external tools, which is already used by VirtualGo is actually using the toml file already, and the metadata that you can actually influence that tool for restores. Constraint is the normal thing that you're using. So in constraint, you define, okay, I want to use the dependency XYZ add version, whatever, and there you can really put a constraint on it. And dep will see that it always ensures you have the highest possible version that still fulfills your constraint. So if you say, I want to use version whatever 1 of Apache Thrift, dep will ensure that you get your security updates, but it won't jump to version 2 if you restrict it on version 1. Override is something I'm putting on the slide, but if ever you read anything about dep, it says don't use override. So I'm not going to talk about it. It's more or less system-wide overrides. It's like using sudo, and you shouldn't use sudo too early. Just try to fix it in other ways. Version is a sub-syntax element of others. I'm just putting it here so you know that this is really everything you need to know about the Go package toml, so don't be afraid of it and just hack in there. Oof, that's easy to read. The version comparison is, like you know from the package JSON in the YAMLs, it's just the same stuff. I never know what to put there. Just know that the default is the whatever you say, Dach in German, and it will make you use the major range of a module, which just totally makes sense. Just put version equals the current version you're using, and everything is fine. Dep will always try to use a version in preference to a revision. Okay, that's clear. Version is a tag. Revision is something that's currently in a branch or in your project, and then branch is preferred to revision. So it's version is the tag, then branch, and then as a last resort, it will use a revision. When it generates the Go package toml, this is how it might look like. Okay, so it actually goes to the source and looks up what it can use and pins you down to versions. And this is I think this is the most important thing when you do dep init. Sometimes you have to work on the toml and fix version strings here initially before it really works. So I think we're coming to an end. The question is, with dep working so well, do we still need to commit the vendor? I think in half a year, I'm not going to commit vendor anymore. I'm going to use dep ensure to actually recreate my vendor directory, but currently I'm using it first to have truly reproducible build. I think dep can now provide that, and I think it's just, I mean, I don't need that line in my build system, but I don't care because the build system has as many lines as it needs, and it's just faster. And the cons is, yes, my repository, I'm mostly using monorepos on all the projects I'm working on, but they're huge, and especially when you have 2 or 3 or 4 Go projects and they all have a vendor directory and they all have their dependencies in there, it's getting huge, and that's really a con. Fortunately, hard drive space is cheap and I don't care. So, and what's also something that bites me at least once a week is the Git diffs are just unreadable. I mean, if you update vendor, it's just huge, and nobody can really check it, and you don't know what's going on in your repository. And yeah, it's a different folder. Yeah, you could still say, okay, git log, ignore vendor, but yes, true. But sometimes you merge a branch, and someone just said dep ensure and update, and then you have it mixed in the branch merge. So it's not a huge problem, but it bites me once a week. Okay, and I think the biggest con, I should have put it on the highest line, is if you are checking in vendor, you forget about dep. Okay, you don't use it anymore because you're actually maintaining your vendor space just very sloppily, and you're not using the tool that you should be using and you should exercise using. Okay, and then for your talk, when you use it in Docker, which is actually why we're using those dependency management tools, is because we need to have recreatable builds. It's just copy first the Go package toml and lock, and say dep ensure, and all this will be cached, and only then add your source code to the Docker image. I think it's a pattern that we know from building JavaScript. So first add dependencies. If the dependency files don't change, then the whole adding dependencies and ensuring dependencies step will be cached, and only then add your source code, and which is a useful pattern, and it works for all Docker. And for library developers, I'm not sure if there are any around here, just follow the guideline that from now on we need to use tags, and it's not good practice anymore to just say, okay, use my library, use head, or use master branch, or whatever. Dep is always trying to find a version, and you're encouraged to use a version. Unfortunately, we use Semver for versioning, but whatever, it's what we do and what we use, and I'm sure they're going to be great tools to manage versioning in your libraries. But also for library developers, I don't know why I didn't put it here, don't check in your vendor directory, please don't, because this will distract the other packages that are actually using your library. So don't do that. And final slide. If you want to read more about it or listen to good talks about DEP and get some side information, I think this is a great talk to get started with DEP. And Sam Boyer's talk is if you want to know why they did it and what's their roadmap. And I think that about sums it up. And yeah, that's the last slide. And if I don't know how we are time-wise. And